Hi, welcome to a Physionic detailed study analysis. Today we're going to be going over the impact that lutein and zeaxanthin carotenoids have on our eye health. So I think I went over 4 or 5 different studies to try to find the answer to that, if they actually impact our eye health, if that's through supplementation or if that's in food consumption. If you're not familiar with who I am, my name is Nicholas Verhoeven. I hold my PhD in molecular medicine, and this is what I do. I take studies, make them, open them up for you, break them apart for you so you can understand the data for yourself and make your own conclusions. That said, I realize that these kinds of videos are not for everyone since they're quite lengthy. So, as a result, there's a conclusion section that you're welcome to skip to. However, you will be missing out on some of the context, some of the clues, some of the details that we'll be going over in the full presentation. Okay, with that said, let's go ahead and get into this real quick. Well, not that real quick because we have a lot to cover. Okay, so as I mentioned, we're going to be covering zeaxanthin and lutein for eye health, but we're also going to go over the mechanisms of action to understand exactly how, or the proposed mechanism of action. If lutein and zeaxanthin have an effect, how would they actually cause that effect? Then we'll go over the clinical evidence of zeaxanthin and lutein on eye health. Then, if you're a Physionic insider, we'll be going over a comparison of different doses for supplementation. What would be the most appropriate dose? What would be the best dose to use? Co-consumption with other molecules. So I'll cover a little bit on that, as well as a comparison of supplementation versus food sources. One of the studies that I covered discussed that to a degree, so I thought I'd cover that as well here. If you're interested in accessing the full version of this analysis, then just hop on over and become a Physionic insider, which is linked in the description box. Okay, let's go over the mechanisms of action. So for this, we're going to be relying on study 311 as well as 312, and you can see the nonprofit funding. So if you want more details on what nonprofit and all that good stuff, then just download the document that I have in the description box, and you will have access to all the studies as well as the funding sources and whatnot. So nonprofit funding. So the information for the mechanisms is going to be based on these 2 studies if you'd like to learn more. All right, so as I mentioned, lutein and zeaxanthin are carotenoids. So they're typically found in plants. And you can see by the sheer size of this molecule that they're pretty long molecules. Now, that actually confers a benefit in their ability to act as antioxidants, and pretty potent antioxidants, because they can quench free radicals or damaging molecules. And I'll show you what that looks like in just a bit. So to familiarize you with your eyeball, we're focused on this region over here. So this kind of yellowish section here called the retina. Now, if we were to dive into the retina, there's a lot of complexity here. However, what we're really focused on is on these cells down here. So the photoreceptors. Photoreceptors are the cells that actually respond to light. If that's high levels of light or low levels of light, we have 2 different types of cells that are responsible for the response to light. So actually converting that light into a reaction that actually goes through our nervous system to our brain so that we can actually realize light and see around us. And those 2 cell types are rods and cones. And that's because the reason why they're called that is because of their shape. So we've got a rod-like shape, we've got a cone-like shape over here. So that's really all you need to know for the time being. But certainly there's a lot more complexity to the eye than just looking at rods and cones. But for the time being, that's what we'll focus on, because that's where lutein and zeaxanthin have their greatest impact. Okay, so as I mentioned, I briefly mentioned free radicals, and reactive oxygen species is, well, I guess I'll mention that now. Reactive oxygen species are another form of damaging molecule. So these molecules, so these ROS in this example, so here we've got our cell membrane. If we zoom into one of these cells, we look at our cell membrane. This is the internal section of the cell. This would be the external section of the cell. And this cell membrane creates the difference between those, or separates the internal from the external. And reactive oxygen species can be generated within our cells, and these damaging molecules can interact with any number of different proteins inside of our cells. So you have all these different proteins that are part of the cell membrane, and they don't actually necessarily have to just interact with cell membrane proteins. They can interact with other proteins that are part of this a part of the cell. So they can be free-floating cytosolic proteins, but just for simplicity's sake, let's just focus on the cell membrane. There's a reason for that I'll get into in just a little bit. So these reactive oxygen species can be produced. They're typically produced by an enzyme called NADPH oxidase, as well as by mitochondria. And mitochondria are the main source of reactive oxygen species generation. It just happens through the simple biological processes. Now, free radicals and damaging molecules in general can actually occur due to any number of different sources. If that's like toxic molecules, if that's through UV radiation, which is what we're going to be focused on. So there are a number of sources of damaging molecules for our cells, but here I'm just showing you a reactive oxygen species. The point is that if you get an accumulation of these ROS, then they interact with these different molecules, these different proteins, and ultimately cause damage to all of them. Therefore, then they are less functional, and then the cell becomes less functional as well. So you can think about, if this is happening to your rods and your cones, then that means that you're going to have a reduced ability to convert light into essentially your perception of vision, your ability to see. So as I mentioned, UV radiation is one of the chief sources of reactive oxygen species and just damaging molecules as well. They damage, UV radiation damages our DNA, which is one aspect, but it can actually also directly damage the cell membrane and the different components of our cells. And since we're talking about rods and cones, it makes sense to focus on UV radiation because that's what we're exposed to. That's what these cells are heavily exposed to, is that's what they're trying to manage. They're trying to manage the actual light and convert that into a signal that then gets translated to the brain. Now, the reason why I was mentioning the cell membrane and the cells and reactive oxygen species is because, as I briefly mentioned earlier, zeaxanthin and lutein are antioxidants, so they can actually interact with these damaging molecules and ultimately neutralize them so that they take upon themselves the damaging molecule and neutralize them so that those damaging molecules no longer interact with different components of the cell, therefore protecting the cells. Now, additionally, not only, if I can go back here real quick, not only do they interact in a free form, but they also interact in a bound form. So the lutein and zeaxanthin can actually be incorporated inside of your cell membrane. And, well, I'll show you an example of why that's so important in just a bit. But not only do they interact with the cell membrane, become integrated into the cell membrane, but they can actually also recruit and interact and bind to these different proteins. These proteins are called antioxidant binding proteins, and lutein and zeaxanthin bind uniquely to different forms of these antioxidant binding proteins. And in so doing, then these proteins themselves, and think of like, if you may have heard of like glutathione, for example. Well, glutathione is one of the potential binding proteins of zeaxanthin and lutein, so that you get more of these proteins that are found on the cell membrane right on the other side of the cell membrane, the closest section to the cell membrane that's on the inside of the cell. So this, the what's known as the intracellular side of the cell membrane, as opposed to the extracellular side. And these damaging molecules then interact with these proteins and get neutralized, as opposed to binding and interacting with the cell membrane and damaging the cell membrane itself. Okay, so this is what I was trying to get to. What's also been shown is that with UV light, now of course this is just kind of a generic cell, but again, when we look at the rods and the cones, they tend to be much longer. But if you ignore that one small detail, and you focus on the fact that these zeaxanthin molecules and lutein molecules are binding to these binding proteins, the antioxidant binding proteins, the free version can actually also be moved to high areas of UV radiation. So there might be a specific area of the cell, specifically the top area, that may be closer to the sun that's coming in, or the light that I should say is coming in, and that you can have a greater concentration of lutein and zeaxanthin in that area of the cell, therefore protecting that area more heavily from UV radiation because it is already subject to greater levels of UV radiation as opposed to maybe further down inside the cell. So they can be transported to high areas of damage and reactive oxygen species generation, which I think is really, really cool. The final thing I wanted to mention here is that lutein and zeaxanthin also localize differently. So zeaxanthin and lutein are easily found in the central area of the retina, so kind of this central area. So here we've got the retinal nerve, but we're talking about anywhere in this area. Then lutein specifically is actually more dispersed across this retina, so on either side of the retina, which I also found interesting, mainly because then it means that lutein probably has a more generalized effect, while zeaxanthin has more of a specific effect on areas that may be, I'm not entirely sure about this, but may be more affected by UV radiation, as in they get exposed to more UV radiation. Zeaxanthin is more concentrated in those areas, while lutein is more spread out across the entire retina. Either way, they both serve a positive function, but it could mean that we shouldn't just focus on, for example, zeaxanthin, because zeaxanthin may not lead to optimal protection on these other areas of the retina. Okay, so let's go over the clinical evidence for zeaxanthin and lutein on eye health. And for that, we're going to be first relying on Study 310, which is nonprofit funding. If you'd like to know more information on the actual funding source and whatnot, I've got a document that you can download with all the studies, and it's got more information on the funding sources. This is a meta-analysis, so they included 46 studies. They didn't report like a risk of bias assessment, which is typically what you would want to do. So that is one weakness of this analysis. Additionally, even though it's 46 studies included, which is really a lot, which is fantastic, and they were intervention trials, meaning that you apply the supplement or you apply the food that has zeaxanthin and lutein, and then you see if there's an effect. Unfortunately, not all of these studies were randomized, double-blind, placebo-controlled trials. So some of them were intervention trials, but maybe not double-blind, so maybe only single-blind, for example. So that's another weakness of this analysis. It doesn't exactly throw out the analysis or anything, but it is something that you should be made aware of. All right, so I teach how to read a lot of this stuff in my course on how to read meta-analyses and how to read randomized controlled trials, but I'll give you a brief walkthrough on a little bit on how to read this. So what the researchers are doing here, I guess I should first explain that we're not looking at the actual eye function. We're looking at MPOD, which is macular pigment optical density. And it's been shown, according to the researchers, that there's a strong correlation between higher MPOD levels and better eye health. So we're not directly probing eye health, which is another weakness of this analysis, I regret to say, but that is the case. So we're not necessarily measuring eye health, we're measuring a proxy for eye health, and that proxy has been strongly attributed to eye health. So just want to be clear about that. Okay, so we've got all the studies on the left side here. They've got things broken up in what's known as a subgroup analysis, which means that They're looking at one group that when people took less than 5 milligrams per day of lutein and zeaxanthin combination, then there's another subgroup of 5 milligrams to 20 milligrams per day, so combination. And then finally, if they consumed over 20 milligrams, and then they're measuring the intervention. So in this case, it's avocados and spinach, which contain lutein and zeaxanthin, versus the actual the actual supplements, versus what they've listed here is the placebo. But as I mentioned, not all the studies were placebo controlled. So I would probably illustrate it as more of a control condition. So essentially not consuming lutein and zeaxanthin. And if it moves more to the right, then that means that it favors intervention, meaning that it favors lutein and zeaxanthin consumption. However, as if you've been following Physionic for a while, you know that we can't just based off of just like our eye test. And I guess even more specifically to read this, what we're looking at here is each one of these squares corresponds to the result, the intervention versus placebo. So the delta, the difference between those two for each one of these studies. So for example, Scott 2017 study, this square corresponds to the actual effect that was seen. So the effect was in favor of intervention, meaning that the MPOD levels increased more in the intervention or lutein and zeaxanthin condition versus the placebo condition or control condition. And you can do that all the way down. Now, these triangles, on the other hand, are indications of the average of all three studies in this subgroup put together, or all, 6 studies of these put together, or all 5 studies here put together. So it's an average result. So if you ever have trouble, distinguishing what's actually happening, one easy way to look at it is just by looking at the diamonds here, which will indicate the overall effect size. And what I can tell you, and I suppose what I was trying to lead into, is that we have to look at the p-values or the statistical test to determine if there's an actual effect. So just looking at this and saying, oh, this diamond is moving towards the right, so it's favoring intervention, that's not good enough. We have to actually look at the statistics themselves as well. And then there's a bunch more that I cover in my course on I-squared and how to think about heterogeneity and a bunch of other stuff that I won't go into right now. But what does this data actually tell us? It tells us that based on these 3 studies with looking at under 5 milligrams per day consumption, there was no benefit to MPOD levels, I should say. So this subgroup indicates no effect. This subgroup of 5 to 20 milligrams indicates there is an effect. And that is not based off these p-values, to be clear. These p-values correspond to the I-squared test, which is a heterogeneity test, which is beyond the scope of what we're going to be talking about. But what the researchers do is they report the p-values in the actual written section of the analysis. So you're just going to have to trust me, or you can open up the study for yourself and read it for yourself, and it'll list it there, the p-values. Typically, I really like it when analyses actually show you the p-value right here for the actual analysis instead of just for the heterogeneity, but it is what it is. Okay, so then the over 20 milligrams condition, there is an increase in MPOD with lutein and zeaxanthin consumption. One quick gripe I would have, and if you've taken the course, you probably already saw this, but this is from a random effects analysis, and there's no heterogeneity. So this is probably the incorrect statistical test to do on this analysis. It's probably not going to change the results, really, probably any, at least not in any way that's actually going to massively change our conclusions or anything. But it's still something I wanted to point out. Anyway. If you consume 5 milligrams or higher, it seems like there's an effect. Now, if you're on the insider version of this, I'm going to be breaking it up like what's the proportion of that lutein and zeaxanthin. We'll be getting into that in the extended version. Okay, study 313, also nonprofit funding. And this is a randomized control trial. And this is really well done, actually. This is randomized, it is placebo controlled, and it's double blind. It's 12 months of treatment, which is really fantastic. It's in men and women, ages 44 to 46. So they have low of that MPOD level. So if you supplement then from there, we'll see if that actually has a profound effect. And they are comparing against a placebo, which is really great. So unlike some of the intervention trials in the last analysis, we're actually looking at a placebo-controlled trial. All right, so as we should usually try to do with any sort of intervention trial, randomized control trial, we should be looking at the baseline values to see if there are any inherent differences between the two groups before the study actually starts. And we can look at the p-values over here. So anything below 0.05 would indicate a statistically significant difference between the two. So then, for example, if we were to look at were there more smokers in one condition versus another condition? Well, smoking could affect eye health, so that may be a confounding variable. I'll go and tell you, though, that was not the case. There were no differences across the board. So there should be relatively even starting points, kind of think of starting a race. They're starting at the same point, and then we're going to see how far they get once they start each intervention, if that's the active intervention, lutein and zeaxanthin, or if that's a placebo. All right. So here we're looking at serum levels of lutein, mesozeaxanthin, and zeaxanthin, because this is a triple combination treatment. And, well, I mean, it would be pretty shocking if the placebo group suddenly saw an increase in lutein and zeaxanthin, and that's not what we find. So this is good news. Over the 12 months, as they're continuing to take their supplements, you can see that serum levels or blood levels of lutein, mesozeaxanthin, and zeaxanthin increase specifically in the active intervention group. Okay, another measure that I briefly talked about, so macular pigment volume. Here we see that there's no change in the placebo group, and we do see that there's an increase in the intervention group. Now, I wanted to point, I added this study also specifically because they don't just look at macular pigment volume, they actually look at actual functional differences in the eye. And I think that's one big advantage of why this study stood out, is that they did it over 12 months. So you probably can't tell any major eye differences, eye health differences, eye function differences if you do the measurements, if you're doing functional measurements like 1 week after supplementation or even a month after supplementation, because it seems like the degradation of the eye happens over long periods of time. Another corollary that I think of when I think of long-term effects is bone mass. So bone mass decreases very, very slowly, but over years, you can actually start to tell a difference if an intervention is actually having an effect. And you probably can't tell a difference if you do it after a month or two. So it's probably the similar situation here. So while macular pigment volume will change maybe statistically after a few months, what we're really interested in is the actual functional outcomes. And that's why I added this data in the analysis. Now, to be clear, I'm not an optometrist, so I haven't done these visual tests themselves, but I'll go ahead and describe what CS and BCVA is. So CS is a contrast sensitivity test, and it's essentially indicating visual acuity. On the other hand, BCVA stands for best corrective visual acuity, so it's looking at a person's visual acuity. And then there are different degrees of fields of vision that are done with this, like 1.2, 2.4, 6, so on and so forth. Just to be clear, again, I just want to remind you, I'm not an optometrist. I mean, I know a good amount about the eye because I study in physiology, but that still doesn't mean that I've actually done these exams. So if somebody who is an optometrist wants to comment and maybe add in a little bit more detail, I would certainly welcome it, and I'll add a note to this presentation. Okay, so what we're looking at here, we've got the mean. We're looking at mean at baseline for placebo and the active intervention. And the point being that they shouldn't be that different from one another, and they aren't. So if we focus on BCVA, for example, 105 to 106, that's not much of a difference, especially with a standard deviation or a spread of the data of 3.79 and 4.26. And you could do that all the way down. So, CS6 CPD, so this sensitivity test 1.68 versus 1.69. Again, it's the same story. And that's a positive because you want them to be as similar as possible. So we looked at the baseline values in terms of their education, smoking habits, and things of that nature, MPOD. But now we're looking at the actual functional differences at the beginning versus 12 months later. And this is that 12 months later. So 12 months later, it goes from 105.67 to 105.7. And the odds that that is statistically significant is very, very low. And the statistics are run on this 12-month value versus this 12-month value over here. And overall, it's not statistically significant, which makes sense. There's basically no change. However, in some of these other tests, like the, CS 1.2 and CS 6, which just as a reminder is the contrast sensitivity tests, there does seem to be a statistically significant effect, as in it improves in the intervention group. So CS6, for example, it moves from 1.68 to 1.76, and this one doesn't budge in the placebo condition, 1.69 to 1.68. And it is statistically significant. So there does seem to be an improvement in actual eye function with 12 months of supplementation with lutein and zeaxanthin. So, and I was really happy to see this because I didn't want to rely simply on an analysis of MPOD for the reason that I mentioned earlier. It's a proxy measure of eye health and eye function, but it's not a direct measure of eye function and eye health. So this is an actual measure of actual physical function of the eye, and it shows improvement. Even if the effect is pretty mild, you're also thinking about this is only 1 year of exposure. It might get better over time. And not to mention that you would think that with macular degeneration, with general eye health decrease, it's going to decrease over time, and this is actually improving. So there's a possibility there that it's not just holding it steady, but actually improving it and making it a little bit younger, which is pretty promising. Okay, the next study is study 315. This is industry funding. Again, if you want more information on that, just download the document that I'll have. Okay, so here, again, it's a randomized placebo double-blind trial. This is in younger individuals. It's age 21. And they are comparing two doses, low dose and high dose. So we've got three conditions, low dose, high dose, and placebo. And they are doing it over 12 months, which is great to see. So, and it is in men and women as well. So a lot of similarity between this trial and the previous trial, but this is in younger individuals. And the previous trial had low macular pigment levels, and this one has good or normal macular pigment levels. Okay, so here we're looking at MPOD again. DG here is disability glare thresholds, which is a measure to assess the impact that these macular carotenoids, lutein and zeaxanthin, have on the ability to maintain visibility of a target in a presence of a glare. And then the final one is to look at photostress. So photostress reaction, this disability glare, and the MPOD. Remember, MPOD is not a direct measure. And I don't think photostress is either, but don't quote me on that. So you want photostress to decrease and you want disability glare to increase. Here we've got the placebo. Here we've got a middle amount, or the low, I guess, amount of lutein and zeaxanthin, and then 24 milligrams, which is the highest amount of lutein and zeaxanthin. And we see that compared to placebo, it is statistically significant. There's an increase in both conditions. So 12 and 24, so low and high amounts, there seems to be improvements in all the metrics. And it doesn't seem like there's that much of a difference between the two. But I'm going to get, again, more into that granularity in the extended version of this analysis. So overall, it confirms the previous analysis and the previous analysis before that as well. So the midpoint conclusion at this point is to indicate lutein and zeaxanthin combination improve macular pigment optic density, so that's a MPOD, which associates with better eye health, and there's a pretty strong association there. However, there's also direct evidence that lutein and zeaxanthin improve eye function. This is achieved by protecting the eye from UV radiation and unnecessary oxidative burden, which I described earlier. Now, if you're going to be continuing on with the insider version of this, I'm going to go over the supplementation versus food sources, as well as the co-consumption with other molecules, see if that has any impact, and the comparison of different doses, specifically how much of lutein and how much of zeaxanthin to consume to get the optimal results. All right, with that out of the way, hopefully you learned something with this episode, this study analysis, and I hope to catch you in the next one. Have a great day. Bye.